Dear students, until yesterday we have discussed the complex numbers topic. Now, complex numbers level 3. Until yesterday we have discussed the complex number level 2 homework problems. Today our topic is complex numbers level 3. Complex numbers level 3. First question. If pi of p is equal to 1 to r e power I p theta, if pi means product, pi of p is equal to 1 to r e power I p theta, e power I p theta is equal to 1, where pi denotes the continued product in the most general value of theta. That implies here pi of p is equal to 1 to r. You can understand as e power I theta into like this. Pi meaning product, e power I theta into e power I of 2 theta into e power I of 3 theta, so on until e power I of r theta, that is equal to 1. That implies e power I theta, you can take it common, so it becomes 1 plus 2 plus 3 plus so on until r, that is equal to 1. Now write here e power I theta into the sigma formula, sigma n r into r plus 1 by 2 is equal to 1. That 1 can be understood as cos 2n pi plus I sin 2n pi, because cos 2 pi plus I sin 2 pi gives the value 1. Sin 2n pi equal to 0, cos 2n pi is equal to 1. Cos 2 pi is equal to 1. If it is becoming n rotations, the value is 1. So you can understand that implies e power I theta into r plus 1 theta by 2, e power I theta into r plus 1 by 2 is equal to e power I into 2n pi. This can be understood as cos 2 pi plus I sin 2 pi or cos 4 pi plus I sin 4 pi or cos 6 pi plus I sin 6 pi, like that anything. But according to the option he given n is there. That is why according to option I have written 2n pi. That implies if bases are equal, both sides, then you can equate powers. So theta into r plus 1, theta into r plus 1 by 2 is equal to 2n pi. We need the most general solution of theta is equal to 4n pi by r into r plus 1. This is the value of theta. Theta is equal to 4n pi by r into r plus 1. Fourth option. First question, fourth option. Second question, z square plus alpha z plus beta, z square plus alpha z plus beta is equal to 0. Alpha comma beta are complex numbers. Alpha comma beta are complex numbers has a real root. It meaning this z square plus alpha z plus beta having a real root, where alpha beta are the complex numbers. Now since it has real root, we can apply x plus I into 0. Given solution here I am writing, given quadratic equation in complex numbers z square plus alpha z plus beta is equal to 0. Z square plus alpha z plus beta is equal to 0. This is 1. Since 1 has a real root, that implies x plus I into 0 is a root. I am thinking simply x is a root. So x is here, z square plus alpha z plus beta is associated with complex numbers, but here we are thinking it is a real root. Whenever it is a real root, then x plus I into 0 we thought. So substitute in 1. So simply x sub in 1. That implies instead of z you write x. So x square plus alpha x plus beta is equal to 0. Let it be second equation. Now taking conjugate of 2. Taking conjugate of 2. Why you are taking conjugate? Meaning according to options. In every option he given alpha, alpha bar, beta, beta bar like that. So that is why if we take conjugate only, then you will get alpha bar or beta bar. Now taking conjugate of second equation, we can write x square plus alpha bar x plus beta bar is equal to 0. It is third equation. Not for x bar, students. Whenever you are taking conjugate for this one, there is no use, because x plus I into 0 conjugate becomes x minus I into 0. No need. So only you are taking conjugate for the complex numbers. Alpha conjugate alpha bar and beta conjugate beta bar. Now 2 minus 3. 2 minus 3. So subtract, then x square will be getting cancelled. X taken common, it becomes alpha minus alpha bar plus beta minus beta bar equal to 0. Alpha minus alpha bar plus beta minus beta bar equal to 0. Therefore, x is equal to, you can write beta bar minus beta by alpha bar minus alpha. Beta bar minus beta by alpha bar minus alpha. So whenever this is a root for this equation, value substitute in second equation. This value sub into we get. Substitute in second equation we get, that implies beta bar minus beta whole square. Beta bar minus beta whole square by alpha bar minus alpha whole square plus alpha into like this beta bar minus beta by alpha. Yeah, this is not alpha minus alpha minus alpha bar whole square. This is alpha minus alpha bar plus beta equal to 0. That implies take LCM here. It is becoming beta bar minus beta whole square plus alpha into denominator becomes LCM as alpha into alpha bar whole square. So you can write here alpha minus alpha bar into beta bar minus beta. Beta bar minus beta plus beta into alpha bar minus alpha whole square. Not this is alpha minus alpha bar whole square equal to 0. Alpha minus alpha bar whole square is equal to 0. That implies according to our option, we can understand here beta minus beta bar whole square or beta bar minus beta whole square, both are same. So beta minus beta bar whole square is equal to these two terms taken that side. You can understand alpha into alpha minus alpha bar into beta bar minus beta into alpha minus alpha bar whole square. That implies beta minus beta bar whole square. Beta minus beta bar whole square. Beta minus beta bar whole square is equal to, multiply carefully, minus alpha into, this is alpha beta bar minus alpha beta minus alpha bar beta bar minus of minus plus alpha bar beta minus beta into this is alpha minus alpha bar whole square expansion alpha square minus 2 alpha alpha bar plus alpha bar whole square alpha bar whole square that is equal to so that I am not changing beta minus beta bar whole square because option given like this one. Now multiply it becoming alpha square beta bar minus of minus becomes alpha square beta. This is alpha alpha bar beta bar minus this is alpha alpha bar beta minus this is alpha square beta minus of minus plus 2 alpha alpha bar beta minus alpha bar whole square beta minus here alpha square beta minus alpha square beta get cancelled. Now 2 alpha alpha bar beta minus alpha alpha bar beta becomes alpha alpha bar beta. Now write like this minus alpha square beta bar and minus alpha bar square beta minus alpha bar square beta right side this side plus you can write here alpha alpha bar beta bar plus alpha alpha this minus this one alpha alpha bar beta alpha alpha bar beta. Okay, now if we take here alpha square beta bar is there, alpha bar square beta is there. Alpha beta bar if we take common among these two terms, alpha beta bar I am taking common. Alpha beta bar. Whenever I am taking common alpha beta bar, then you can write alpha bar. Yeah, minus alpha taken common alpha beta bar. So this is alpha. Yeah, alpha. Next one, between these two terms, you take common alpha bar beta. If you take minus with minus alpha bar beta, now you can understand this is alpha bar and this is alpha bar beta taken common, it is alpha. So once again you can take common alpha bar minus alpha into alpha beta bar minus alpha bar beta. Therefore, the value now we should write here beta minus beta bar whole square is equal to alpha bar minus alpha into alpha beta bar minus alpha bar beta into alpha beta bar minus alpha bar beta or beta minus beta bar whole square is equal to alpha minus alpha bar into alpha bar beta minus alpha beta bar. According to option given as beta minus beta bar whole square equal to alpha bar minus alpha into alpha beta bar minus alpha beta alpha bar beta. This is option 3. Option 3. Now third question is going on. Third question, if Z1, Z2 are complex numbers such that Z1 not equal to Z2, mod Z1 is equal to mod Z2, Z1 has a positive real part and Z2 has negative imaginary part, then Z1 plus Z2 by Z1 minus Z2. Procedure is there, but according to condition put shortcut it is better. He is discussing with that Z1 not equal to Z2. So that meaning two complex numbers are not equal but their magnitudes are equal. And Z1 has a positive real part and Z2 has a negative imaginary part. Z1 has a positive real part Z1 plus like this, right? Z1 is equal to 1 plus I and Z2 is equal to 1 minus I because it is negative imaginary. Now apply the value. Now Z1 plus Z2 by Z1 minus Z2. Z1 plus Z2 by Z1 minus Z2. That is equal to 1 plus I plus 1 minus I whole by 1 plus I minus 1 plus I. Here I will get cancelled, here 1 minus 1 get cancelled. We got 2 by here, 2 by 2 I can understand as 1 by I multiplied divided with I, it becomes I by I square, so it is minus I. So it is simply purely imaginary. There is no real part. Purely imaginary. Option 1 is correct. Purely imaginary. Now, fourth question. Fourth question is that the condition that x power n plus 1 minus x power n plus 1. X power n plus 1 minus x power n plus 1 is divisible by x square minus x plus 1. Then what is the value of n? Here you can understand if n is equal to 1, students, it becomes x square minus x plus 1. This is x square minus x plus 1. By mathematical reduction, n is equal to 1, it is true. Whenever x square minus x plus 1 equal to 0, then you can understand omega and omega square both are roots. Not omega here, minus omega for this one. For x square minus x plus 1, minus omega comma minus omega square are roots. Minus omega comma minus omega square are roots. Now substitute the value here, minus omega whole power n plus 1 minus omega whole power n plus 1 plus 1. Now putting the value or substituting the value, verifying option 1 I am writing n is equal to 6k plus 1. N is equal to 6k plus 1. Put n is equal to 6k plus 1 minus 1 whole power 6k plus 2. Minus 1 whole power 6k plus 2 minus 1 whole power 6k plus 1 plus 1. One thing you should remember the value. Summation of roots of nth roots of unity equal to 0 if they are not multiple of n. I mean 1 plus omega square equal to 0 if it is not multiple of 3. 1 power 1 by 3 becomes 3 roots. Omega 1 omega square. It is called as cube roots of unity. 1 omega power 1 omega power 2 is not at all multiple of 3. Whenever it is not at all multiple of 3, even though 1 plus omega power 4 plus omega power 5, it is also can be understood as 1 plus omega square. The sum is always 0 if it is not multiple of n. If it is multiple of n, I mean 1 plus omega power 3 plus omega power 6 plus omega power 9, like that the value is n. So 1 plus, example 1 plus second one omega cube plus omega power 6 becomes 1 plus 1 plus 1 becomes 3. So if you are taking the 3 roots, you will be getting value 3. If you are taking 4 roots, you will be getting value 4, like that. Why you are discussing that concept here? If it is not multiple of 3, then only it is 0. 3 multiples here according to options. First option and third option is there. Minus 1 you should not consider. No. If you are verifying here, minus omega 1 power 6k. K should be any integer he might have given. Minus 1 omega 1 power 6 whole power k into this can be understood as omega square. Minus of minus 1 whole power 6 whole power k into omega plus 1. Of course, we know that omega power 6 is equal to 1. Minus 1 whole power 6 becomes positive, it is plus 1. So now you can understand this directly 1 into omega square. This is omega square minus of, this becomes minus here. Minus omega power 6 into, this can be understood as minus omega. This is minus omega. So omega square plus omega plus 1 is equal to 0. So it is satisfying. But omega, next maybe omega power 3k plus 1 will not satisfy. Omega power 3k plus omega into omega power 3k plus 2. If n is equal to 3k plus 1, x to power n plus 1, it becomes 3k plus 1. If it's 3k plus 2 minus omega power 3k plus 1. So omega square minus omega, it is also correct only, shall be divisible by maybe first and third, both are correct. He given only first option. That you verify, students, you verify whether it is possible or not, third option. Now fifth question. AZ1, BZ2, CZ3 are the vertices of an equilateral triangle ABC, and the value of argument of Z1. Better to take this is A, this is B, this is C here. We know that 1 comma omega square forms an equilateral triangle. I am writing like this. We know that 1 comma omega square forms 1 comma omega square forms an equilateral triangle. So A 1 comma 0, B this is Z1, B this is Z2. Z2 I am writing the value omega minus 1 by 2 comma root 3 by 2 minus 1 by 2 comma root 3 by 2. This is Z2. So Z2 is value minus 1 by 2 comma minus root 3 by 2, because omega value is minus 1 plus I root 3 by 2 and omega square value minus 1 minus I root 3 by 2. Now what he is asking, argument of Z2 plus Z3 minus to find out argument of Z2 plus Z3 minus 2Z1. Z2 plus Z3 minus 2Z1 by Z3 minus Z2 is equal to what? Now apply the concept. Argument of Z2 meaning here minus 1 by 2 minus I root 3 by 2 like this. Minus 1 by 2 minus I root 3 plus this, no, this is plus Z2 meaning. Z3 meaning minus 1 minus I root 3 by 2 whole by 2 minus 2Z1. Of course it is 2 into 1 whole by Z3 minus Z1. So this is minus 1 minus I root 3 minus of minus becomes plus 1 minus I root 3 plus 1 minus I root 3 whole by 2. Now here minus 1 I root 3 get cancelled. I root 3 get cancelled. It becomes argument of minus 2 by 2. Argument of minus 2 by 2 becomes minus 1 minus 2 whole by minus 1 minus 2 whole by, this is here minus 1 plus 1 get cancelled. Minus I root 3 minus I root 3 becoming minus 2 I root 3 by 2. This is minus I root 3. This is minus I root 3. That is equal to argument of minus 3 by minus I root 3 minus 3 by minus root 3 I minus get cancelled. This will be dividing root 3 times argument of root 3 by I. Argument of root 3 by I. The argument of root 3 by I, better to multiply and divide with I. Argument of root 3 by I, multiply and divide with I. It becomes argument of I root 3 by minus 1. So minus I root 3, right? Here you can understand that only imaginary part is there, there is no real part. Now for argument we write theta is equal to tan inverse imaginary part by real part. Theta is equal to tan inverse imaginary part by real part. Therefore theta is equal to tan inverse real part is, there is no real part. So you can write root 3 by 0. Tan inverse root 3 by 0 becomes tan inverse infinity. So write like this, it is tan inverse of infinity. Tan inverse infinity So tan infinity becomes for how many degrees? It is for 90 degrees. This is tan inverse root 3 by 0. Tan inverse root 3 by 0, you can understand theta is equal to here the argument of this one. Theta is equal to tan inverse of root 3 by 0. So theta is equal to tan inverse root 3 by 0 becomes infinity. Tan inverse infinity meaning pi by 2. So argument of this complex number using the given condition is pi by 2. Now, sixth question. The distance of the roots of the equation modulus of sin theta 1 into z cube plus modulus of sin theta 2 into z square plus modulus of sin theta 3 into z plus modulus of sin theta 4 is equal to 3 from z equal to 0 on. The distance of the roots of the equation from this one. The distance of the roots of the equation sin theta 1 into z cube plus sin theta 2 into z square plus sin theta 3 into so on. Given, you write like this. 3 is equal to modulus of sin theta 1 into z plus modulus of sin theta 2 into z square plus modulus of sin theta 3 into z plus modulus of sin theta 4. We know that minus 1 less than or equal to sin theta less than or equal to 1. So that meaning itself is mod sin theta less than or equal to 1. So the maximum value of mod this becomes 1. For complex numbers, take mod for all and take mod for all both sides. That implies mod 3. This is equal, you can understand, modulus of z cube. Okay, modulus of sin theta I am writing simply 1. So directly you can understand modulus of z cube. For separately I am writing modulus of z cube plus modulus of z square plus modulus of z plus modulus of 1. This total value lesser than or equal to equal to 1 plus 1 like that. You can understand this one lesser than or equal to, because I can less than or equal to 1. If you take maximum value here, you can apply here. This is lesser than or equal to modulus of 1 plus. So total modulus. You should not write like this. Total modulus. Later we should apply the squad G equality. This is like this. Modulus of z cube plus z square plus z plus 1. This is less than or equal to like this. Modulus, separate modulus of z cube. According to squad G equality, you have applied total terms less than or equal to separate terms. Modulus of z cube plus modulus of z cube plus modulus of z square plus modulus of 1. This one, how many numbers are there? Only 4 numbers are there. 1 z square like this. This one totally, for this one I am discussing with you that 1 plus modulus of z plus modulus of z square plus modulus of z plus modulus of z square plus modulus of z cube plus so on until infinity terms. So total infinity, total terms maybe example 5. This is only 3 like this. Example 1, 1, 1, 1 you take. This is infinity. So large value is greater than 4. So whatever the value is 4, this is always less than this one. So less than only, there is no question of here equal to less than. If everything is 0, then it becomes Everything is 0, so our complex number is 0. Directly we can write less than here. That implies now from here you can understand 3 less than or equal less than 3 less than. This is the formula of infinite geometric progression. For infinite geometric progression, apply the value of a by 1 minus r. A by 1 minus r. Here 1 by 1 minus modulus z. That implies apply now 3 into 1 minus modulus z less than 1. That implies 1 minus modulus z less than 1 by 3. 1 by 3 taken this side, it becomes 2 by 3 less than modulus. Therefore, modulus z greater than 2 by 3. What is the meaning of modulus z? It is the x plus, if z is equal to x plus I is any complex number, root of component square plus component square is the nothing but distance between the origin to the point. What he is discussing with us about the distance of the root of the equation, roots of the equation from z equal to 0, meaning is nothing but origin. So it is nothing but mod z greater than 2 by 3. So answer is first option here, greater than 2 by 3. Now seventh question is that let A be the complex number such that mod A less than 1 and Z1, Z2 so on be the vertices of polygon such that Zk is equal to 1 plus A square plus so on A power k minus 1. Let A be a complex number given A be a complex number. Given A be a complex number with mod A less than 1. Z1, Z2 are vertices of polygon such that condition I am writing here. Condition Zk is equal to 1 plus A square plus A cube plus so on until A power k minus 1. A power k minus 1. Then the vertices of polygon lies within a circle. They are according to condition. Here you can understand this one as this is GP. In the GP, this is yes. GP direct in the form of 1 plus A plus R plus R square so on AR power n minus 1. So SL is equal to here A into the formula I am writing 1 minus R power n by 1 minus R because R less than 1 already given mod A less than 1. So apply the formula. What is R here? A. So A means 1 into 1 minus A power k whole by 1 minus A. The term implies right like this. Zk is equal to 1 by 1 minus A, separately right, minus A power k by 1 minus A. Minus A power k by 1 minus A. This one taken left side. Zk minus 1 by 1 minus A is equal to minus A power k by 1 minus A. Take mod both sides. Take modulus both sides. That implies modulus of Zk minus 1 by 1 minus A is equal to minus of modulus of A power k by 1 minus A separately you can take. That implies modulus of Zk minus 1 by 1 minus A is equal to A power k by 1 minus A. A power k by 1 minus A is given mod A less than 1. So whenever this is 1 minus A power k we got. According to option this one, mod A power k, mod A less than 1 is there. Mod A power k should be 1. He might have given A be a complex number such that mod A less than 1, Z1, Z2, Z3 is the vertices of polygons such that Zk is equal to 1 plus A plus A square plus so on. Let us see the question. Okay. According to squad G equality, once again you should write this one like this. This is less than or equal to 1 by 1. This is less than or equal to 1 by 1 minus A. This is less than 1 by 1 minus A. 1 by modulus of 1 minus A. Because mod A less than 1, whenever mod A less than 1, you can apply less than 1. That implies modulus of Zk minus 1 by 1 minus A. Minus 1 by 1 minus A less than this answer 1 by 1 minus A. Or of course is equal to also you can put this meaning is that draw a circle. Mention the points in the circle. Like this. Points. Because Zk meaning Z1, Z2, Z3, so on, so many points. We can write this is a circle. This is a circle having a center. This is a circle having a center 1 by 1 minus A comma 0. Having a center 1 by 1 minus A comma 0. If I is there, then you can understand 0 for this one also you can put any number. 1 by 1 minus A comma 0 and radius 1 by 1 minus A. Radius is equal to 1 by 1 minus A. The locus is interior of such a circle. Means so many points Zk, modulus of Zk minus 1 by 1 minus A. Whenever it is less than 1 by 1 minus A, it is interior of the such circle. Meaning like this, interior of such circle. So according to our option, we can understand polygon within circle. Whenever within circle, directly he is mentioning that point. So he is discussing with us that every point is inside of circle. So what is the equation of circle? Z minus this one, third option. Modulus of Z minus 1 by 1 minus A is equal to 1 by 1 minus A. Option 3. Verified. Option 3. Now, 8th question. Eighth question. If at least one value of complex number Z equal to x plus I satisfy the condition mod Z plus root 2 is equal to condition mod Z plus root 2. Mod Z plus root 2 is equal to root of a square minus 3a plus a square minus 3a plus 2. If Z is at least any one complex number, satisfy Z plus root equal to mod root of a square minus 3 plus 2 and another inequality. Another one is given Z plus I root 2. Z plus I root 2 less than a. So according to domain concept we can write this is a circle. This is a circle having a center. This is a circle having a center minus root 2 comma 0. You can understand if you put x plus I by here, x plus root 2 plus I by, so x minus half minus root 2 plus I by. So this is minus root 2 comma 0 and radius. Having a circle minus root 2 comma 0 comma radius root of this one. Radius is root of a square minus 3a plus 2. Root of a square minus 3a plus 2. For this one. This is a circle having a center. Now you can understand 0 comma minus root 2 because here I is 0 comma minus root 2 and radius. Radius is equal to root a. Here root of a square minus 3a plus 2 is there. Here this is root a. So root of maybe because z plus root of this is root a. Of course we know that a square minus 3a plus 2 greater than 0. Of course greater than or equal to 0. If he is not mentioning it is a point circle, if it is a point circle and there is no complex number, simply everything is 0. Whenever root 2 is there, it is not point circle. So there is a point, whenever it is point circle, you can apply radius is 0. So I am taking it is not point circle, so any square greater than or equal to 0, so radius greater than 0. Now you can understand this one, a minus 1 into a minus 2 greater than 0. Everyone knows that the concept a does not belongs to 1 comma 2. That means a less than 1 comma a greater than 2. Here root a, of course it is a greater than plus simply leave it. Common domain we can write. For both common domain concept. Here a greater than 0 is mentioning and a greater than 2 is there. So you can say that simply this is a greater than 2. So according to the option, a greater than 2 is first option. A greater than 2 is first option. Now 90%. Concept of 90%. Concept of 90% is that sum of roots of nth roots of unity, sum of nth roots of unity is equal to 0 when it meaning root, it is not multiple of n, meaning example omega power 1 by 1 power 1 by 3, 1 plus omega plus omega square equal to 0 like that. If it is multiple of n, then it is the value is n. And another concept I am going to discuss with you that a plus b plus c whole square formula, a square plus b square plus c square plus 2 into ab plus bc plus ca. Of course, for a plus b whole square it is a square plus b square plus 2ab. For everything, whenever you are doing the square of plenty of terms, first of all we will get like this: first term square plus second term square plus third term square plus so on, 2 into first into second into third like this. Now, according to theory of equation also we can solve the question. Now, alpha 1, alpha 2, alpha 2. So on alpha 100 are 100 roots of unity. Alpha 1, alpha 2, alpha 3. So on alpha 100. Alpha 1, alpha 2, so on 100. Alpha 100, 100th roots of unity. 100th roots of unity. 100th roots of unity. Now the numerical value to find 100th roots of unity. To find what we should find? To find is giving the 2 into sigma 1 less than or equal to I less than or equal to j less than or equal to 100 into sigma alpha I alpha j whole in power 5. The value is dash. Originally he should not mention double sigma here. This is enough. Why he mentioned here meaning the value may be, let us verify whether why he given. He should not give. Okay, even though he gives are no problem. Discuss now. Consider alpha 1 power 5 like this. alpha 1 power 5 plus alpha 2 power 5 plus alpha 3 power 5 plus 1 alpha 100 power 5 because alpha 1 alpha 2 alpha 3 so on alpha 100 roots. We need to get alpha in the alpha j. Just wait and see. Alpha 1 alpha 2. What I said the formula sum of nth roots of n equal to 0 if it is not multiple of n. Here you can understand 5 is not at all multiple of 100. Students don't get confused. 5 is not at all multiple of 100. 100 is multiple of, okay, 100 is divisor of 5. 5 is divisor of 100, okay, 5 into 20. But 100 into what is equal to 5? It is not there. 500 is multiple of, like this. 200 is multiple of 100. 300 is multiple of 100. But 5 is not at all multiple of 100. Whenever it is not multiple of n, directly you can understand it is 0. Now squaring works. Now squaring works. For this one I said the concept. Alpha 1 power 10. Alpha 1 power 5 whole square like this. Alpha 1 power 10. Alpha 2 power 10. Alpha 3 power 10 plus 1. Alpha 100 power 10. Here general notation 1 plus omega square like this. Here 1 is nothing but alpha. So 100 roots. Here this is like this. Plus the formula is among if you take only 3 terms you can understand plus 2 into. Now you can understand students 2 AB concept. 2 into alpha 1 alpha 2 like this. Next alpha 1 alpha 3. Next is 1 alpha 1 alpha 100 like this. You can understand now it is alpha 2 alpha 3 plus alpha 2 alpha 4 plus 1 at last it is alpha 2 alpha 100. Next plus alpha 3 alpha 4 like this. Alpha 3 alpha 4 plus alpha 4 alpha alpha 3 alpha 5 like this. Plus 1 alpha 3 alpha 100. In the similar way you can able to understand like this. Alpha 99 alpha 100. Until here you can say this is alpha 99 alpha 100. Alpha 99 alpha 100. This total answer is 0. Now you can say the meaning of here alpha I alpha j 1 less than equal to I less than j b 1 2 1 3 1 4 like this. And what is I, what is j? I is always less than the value j. Now this one I said alpha power 1 alpha 1 power 10 plus alpha 2 power 10 plus so on. It is also 0 because 10 is not multiple of 100. It is also 0. 10 is not multiple of 0. Then you can understand this is a 2 into directly I am writing sigma where 1 less than or equal to I less than or equal to j. This is alpha I alpha j. Of course anything whole power 5 maybe 2 into AB plus BC plus CA concept. Alpha 1 this is 0 of course 0 power anything 0. This is 0. Now whenever it is becoming 0 power 5. Now I am applying students like this. Double sigma 0 power 5 is 0. Now 2 less than or equal to 2 sigma 1 less than or equal to I less than or equal to j less than or equal to 100 half sigma of course it is 0. So alpha I alpha j whole power 5 the total value is 0. Now play 10th question. The center of regular polygon of the center of regular polygon of n sides. Put n is equal to 3 I am writing. Whenever he is discussing with us, put n is equal to 3 and regular polygon he is discussing. So consider equilateral triangle. Consider an equilateral triangle. Equilateral triangle. He is discussing with us the center of regular polygon of n sides located at z is equal to 0. One vertex is z1 and other is z2 of adjacent bodies. Recovering here A, this is z1, put here B, this is z2, put here yes, this is z dot, z equal to 0. Draw like this, draw like this. For equilateral triangle, we know that here everything pi by 3. This is also pi by 3 angle. Every angle is equal. Here every angle is equal. Then it becomes 2 pi by 3. 2 pi by 3. So according to Coni's theorem, if this is ABC, it is alpha. Coni's theorem. Coni's theorem, we have discussed that AB by this common letter by CB is equal to modulus of AB by modulus of CB into e power I alpha. AB by CB, like this, e power I alpha. So like this to this and this to this already discussed. Common letter B, angle is the common letter. This AB and AB, this is the Coni's theorem. Now you can apply here AS by BS, like this. I am writing this one also. Mention here angle S. S is 2 pi by 3 because the formula of triangle concept. This is S and this is B. Now this is Z1. S is of course nothing but 0, 0 because he said that Z is equal to 0. This is B, Z2. This is B, Z2. Now that implies by Coni's theorem we have apply the concept AS by BS. AS by BS is equal to modulus of AS by BS into e power I 2 pi by 3. Now you can apply AS meaning Z1 minus 0, it is nothing but Z1 by Z. Otherwise Z2 by Z1, we is discussing this BZ2. Of course any day you can write BS by AS because he is discussing B regarding this. BS by AS is equal to modulus of BS by modulus of AS into e power I into 2 pi by 3. So right here this is Z2 by Z1 is equal to, we know that SA is equal to SP is equal to SC in any triangle. So it is equal. So you can write this is cos 2 pi by 3 plus I sin 2 pi by 3. Therefore Z2 is equal to Z1 into, according to our option, cos 2n pi by 3 plus or minus I sin 2n pi by 3. That is why I said maybe you can take rotation negative side or positive side. So cos 2n pi 2 pi by n because 2 pi by 3 enough, simply not n. 2 pi by 3 leave it. You write now this is 2 pi by n, cos 2 pi by n plus I sin 2 pi by n because I have taken only n is equal to 3. For n-sided regular polygon, you can apply it is n. Okay, students, you have successfully completed 10 questions. Let us going to discuss the questions, remaining questions in next class.